Recall from lesson 3.6 that the graph of a compound inequality with the word "and" contains the overlap of the graphs of the two inequalities that form the compound inequality. You can think of the overlap as the intersection of two sets. Here we have the graph of x is greater than or equal to 3 and the graph of x is less than or equal to 7. This graph represents that intersection of sets. X is greater than or equal to 3 and x is less than or equal to 7. This Venn diagram shows the intersection of the two sets. Similarly, you can think of the solutions of an OR inequality as the union of two sets. Problem 5. Writing solutions of an inequality. What are the solutions of the absolute value of 2x minus 1 is less than 3? Write the solutions as either the union or intersection of two sets. So note our absolute value part of the expression is already isolated. So we break this into two separate inequalities. Note in this case they can be written as a compound inequality where negative 3 is less than 2x minus 1, which is less than 3. We solve by adding 1 to each part of the inequality, so to the left, to the middle, and to the right. And we have negative 2 is less than 2x, which is less than 4. Now we divide all three parts by 2, and we find negative 1 is less than x, which is less than 2. So the solutions of the inequality are given by the compound inequality. Negative 1 is less than x, which is less than 2. And you can write this as x is greater than negative 1 and x is less than 2. This compound inequality is the intersection of two sets, which you can write as follows. The set x such that x is greater than negative 1 intersect the set x such that x is less than 2. Your turn. Solve 8 is less than or equal to x plus 5, which is less than 11. Write the solution as either the union or the intersection of two sets. And B, solve the absolute value of 4x minus 6 is greater than 14. Write the solution as either the union or the intersection of two sets.